Imagine a world, not of ancient ruins, but of tiny, perfect spheres. Smaller than your fingertip, yet carrying a secret so vast it could rewrite everything we know. What if we are not the first? What if others came before, lived on this very earth, and left behind only these whispers in stone? We have always believed our civilization stands alone, the first to unlock the atom, to reshape the planet, to build machines that defy nature. But deep within ancient rock, in prehistoric ice, and hidden in ocean mud, silent clues suggest a different story. Metallic spheres, forged by unimaginable heat. Sudden, inexplicable spikes of carbon frozen in time. Traces of radiation locked in stone, millions of years before humanity ever existed. These aren't just anomalies, they are fragments of a haunting question. It's called the Curran hypothesis, proposed by scientists like NASA's Gavin Schmidt and astrophysicist Adam Frank. It asks, if advanced civilizations rose and fell on Earth long before us, what does their fate mean for our future? Our journey into Earth's forgotten past begins not with colossal structures or giant bones, but with something so small it's easy to miss. Tiny metallic beads, some no bigger than a grain of sand, others small enough to balance on your finger. These spheres have been encased in ancient rock for spans of time almost beyond comprehension. Their very existence forces us to confront a fundamental question: are we truly the first intelligent life to walk this planet? To understand why these minuscule objects are so unsettling, we need to look at their modern counterparts. When the first nuclear bombs detonated in the mid-20th century, scientists meticulously studied the aftermath. They found the expected devastation: vast craters, shattered buildings, scorched landscapes. But they also found something profoundly stranger. The immense heat of the explosions had vaporized soil and stone, turning solid earth into a molten cloud. As those superheated materials cooled and fell back to earth, they formed perfect, glassy beads. These are known as microspherules, and they are one of the clearest geological fingerprints of nuclear fire. Fast forward millions of years. If another species were to dig into our planet long after we are gone, they wouldn't find our concrete cities or our orbiting satellites. But they would find these microspherules, scattered through the soil, a silent testament. Even if every other trace of our existence vanished, these little beads would remain, telling a story. Someone here, once, learned to split the atom. That knowledge makes the discoveries in ancient rock truly haunting. Nearly identical metallic spheres have been found in geological layers far, far older than humanity itself. In South Africa, miners cutting into deposits of pyrrolite, a soft rock used in industry, stumbled upon hundreds of them. Some were smooth and perfectly spherical, as if machined. Others bore fine grooves etched around their middles, resembling manufactured ball bearings. Their composition was metallic, with unusually high levels of hematite and other minerals not expected in such a natural context. Most shocking of all, the rock encasing them was over 3 billion years old. This was a time when Earth was a hostile, microbial world. By every scientific understanding, no complex life, let alone anything capable of precision engineering, should have existed. These mysterious objects became known as the Klarkstorp spheres, and ever since their discovery, they have been a quiet, persistent controversy. Officially, geologists often argue they are natural concretions, unusual but not impossible formations created when minerals cluster together under specific conditions. But skepticism persists. Some of the spheres are so perfectly balanced they can roll straight across a flat surface with remarkable precision, a feat even modern machining struggles to achieve consistently. Photographs showcasing their flawless symmetry and neat, carved grooves only deepen the debate. And the mystery isn't confined to South Africa. Similar metallic microspherules have been discovered in other parts of the world, sometimes embedded in layers tens of millions of years old. Many contain nickel and chromium in unusual ratios, strikingly similar to those produced in modern metallurgy and, more disturbingly, in nuclear detonations. Volcanic eruptions and asteroid impacts can also create spheres. However, their chemical profiles typically do not match what we see in these ancient samples. Natural processes tend to yield wide variations. These spheres are consistent, uniform, almost as if mass-produced. Even more intriguing, some layers rich in these metallic microspherules align precisely with mass extinction events. Entire ecosystems vanished, and in the very same strata, geologists find this peculiar scattering of metallic spheres. Mainstream explanations point to asteroid impacts or prolonged volcanic winters as the cause of these extinctions. But another possibility lurks in the data, a whisper that at least some of these layers mark not natural disasters, but technological ones. Nuclear fire, fallout on a global scale. It is crucial to be cautious here. Extraordinary claims demand extraordinary evidence, and a handful of unusual spheres is not enough to completely rewrite the timeline of civilization. Yet, the coincidence is strikingly hard to ignore. Because if an advanced society once thrived on Earth, these spheres are precisely the kind of clues we would expect to survive its collapse. Not their sprawling cities or their intricate art, which would crumble to dust, but the enduring chemical and geological scars of the immense forces they unleashed. Imagine, for a moment, a distant future. Millions of years from now, long after humanity is gone, our concrete structures will have crumbled, our steel will have rusted away, and our glass will have turned back into sand. But a thin layer of radioactive isotopes will remain in the soil. Tiny fragments of plastic will be trapped in the deepest oceans. And scattered through the sediments will be billions of microspherules, the enduring legacy of our nuclear age. Future scientists would not need to see our monuments to know we once existed. They would only need to find these unmistakable fingerprints. And so, we are left with an uncomfortable symmetry. In our present, our own technology leaves behind markers that future civilizations could recognize. In Earth's deep past, we find markers that look almost identical, but with ages that utterly defy our established history. If they are merely natural oddities, they are remarkable, perplexing coincidences. If they are artificial, then we are not the first. The truth remains buried in stone, silent and defiant. But the very existence of this debate forces us to look closer at the other puzzles Earth has left for us. Because the mystery of these metallic spheres is only the beginning of our hidden history. Now, when we turn to the story of life itself, preserved in the fossil record, we find gaps so vast, and leaps so dramatic, they fundamentally challenge our understanding of evolution. Patterns that almost feel like the work of unseen hands, nudging life forward, or erasing it altogether. And that is where our journey leads next, into the fossil record. A book where entire chapters are missing, and where the pages that remain hint at something far stranger than natural history alone. The fossil record is often described as a book, a long, detailed story of life on Earth. But when you actually open that book, what you find looks less like a smooth narrative, and more like a jigsaw puzzle with half its pieces torn away. There are sudden, inexplicable appearances, and entire chapters that seem to have been violently ripped out. And the deeper you look, the stranger it gets. The most dramatic example comes from what scientists call the Cambrian explosion, roughly 540 million years ago. For billions of years before it, life was overwhelmingly simple, mostly microbes, algae, and tiny, basic multicellular organisms. Then, almost overnight, in geological terms, the world changed. Creatures with shells, with eyes, with complex nervous systems, and intricate body plans appeared seemingly out of nowhere. Dozens of new phyla, the highest categories in biology, emerged within just a few million years. That may sound like a long time, but on the scale of Earth's history, it's a mere blink. Evolutionary theory tells us that life changes gradually, through mutation and natural selection. In many cases, the fossil record supports this slow, steady progression. But during the Cambrian, the rate of change seems almost impossible. Instead of slow, branching diversification, it looks like an explosion of complexity. Charles Darwin himself admitted it was one of the greatest puzzles for his theory. Today, scientists explain it by suggesting that environmental conditions suddenly became ideal for better fossilization, or that genetic thresholds were crossed, enabling rapid diversification. And perhaps that is true. But there is another possibility, one most scientists avoid, yet it lingers like a shadow. What if something else was pushing life forward? The Cambrian explosion isn't the only anomaly. Again and again, across the hundreds of millions of years that followed, we see sudden arrivals of entirely new species, with little or no clear sign of ancestors. Mammals appear, then diversify rapidly after the dinosaurs vanish. Flowering plants dominate ecosystems seemingly overnight. Even humans appear strangely quickly, with brains that tripled in size in just a few million years. Each of these leaps could be explained by chance, a fortunate convergence of factors. But when you line them up, the pattern begins to look suspiciously purposeful. And then there are the extinctions. 5 times in Earth's history, nearly all life was wiped out in global cataclysms. Asteroids, supervolcanoes, shifting climates, these are the standard explanations. But what if, in at least some cases, these extinctions weren't purely natural? What if they were the collapse of civilizations we have forgotten? Their end marked not by craters and lava, but by their own devastating mistakes. If we disappeared today, the sudden vanishing of most large animals, elephants, whales, vast herds of livestock, would profoundly puzzle any future scientist. They might initially attribute it to climate change or a cosmic impact. Only by digging deeper, into the chemistry of the rocks, would they slowly discover the truth. It was us. The fossil record is inherently incomplete. Soft-bodied organisms rarely leave traces. Entire environments vanish without a mark. But sometimes, what is missing tells a story just as loudly as what remains. When life makes leaps that seem too big, or vanishes without a clear, natural cause, it forces us to consider possibilities outside the usual explanations. Maybe the record looks broken because the story of life itself has been interrupted, reset, or guided in ways we don't yet understand. And if that is true, then life's history is not just random chance. It may be the layered record of civilizations rising, influencing the world around them, and then vanishing. Their traces left not in monuments, but in the strange, rhythmic patterns of evolution itself. But fossils aren't the only record of the past. If civilizations altered Earth, their fingerprints might not just be found in bones and shells, but in the very air itself. And that brings us to another anomaly, frozen in ice and locked in our atmosphere. Evidence that looks eerily like the scars of ancient industry. One of the most powerful tools scientists use to study Earth's past is ice. In Greenland and Antarctica, cores drilled deep into glaciers reveal tiny bubbles of air trapped tens of thousands, even hundreds of thousands of years ago. Each layer of ice is like a snapshot of the atmosphere at the precise moment it formed. By analyzing these trapped bubbles, we can reconstruct the climate, charting rises and falls in temperature, carbon dioxide, and methane across vast ages. It's like opening time capsules from Earth's breathing past. Most of the patterns we observe are natural, ice ages waxing and waning, carbon cycling with the growth of forests and oceans. But here and there, something profoundly strange appears. Layers where carbon dioxide spikes dramatically, then stabilizes again, almost as if something had rapidly burned huge amounts of organic material. Sudden pulses of methane, far beyond what natural wetlands or volcanoes could possibly produce, appear in some ice. Faint, persistent traces of compounds that simply don't belong at all. Chemicals that look suspiciously like industrial byproducts. The official explanations are always cautious. Perhaps massive wildfires raged across continents. Perhaps volcanoes released unusual combinations of gases. But the sharpness of these spikes, and the uncanny way they echo what we are doing right now, is unsettling. Our own industrial footprint is unmistakable. Carbon dioxide rising faster than in any natural cycle in millions of years. Methane surging from agriculture and industry. Synthetic chemicals drifting into the sky, global pollutants. If we vanish tomorrow, those distinct markers would be locked into ice and sediments for millions of years to come. And so, when we find remarkably similar markers in layers dating long before humanity, we have to ask, who, or what, put them there? There is also the problem of ancient warming events. Geologists have identified periods when Earth's temperature suddenly grew hotter, far beyond normal climate swings. One of the most famous is the Paleocene-Eocene thermal maximum, about 55 million years ago. During this period, temperatures spiked globally, oceans acidified, and ecosystems collapsed worldwide. The causes are debated: intense volcanic activity, massive methane release from the ocean floor, or perhaps even an asteroid impact. But the chemical signatures in the carbon look disturbingly like what you'd expect from the massive burning of fossil fuels. The very same fingerprint we are leaving today. Was it just a natural coincidence? Or was it the industrial scar of a forgotten civilization that burned too hot, too fast, and ultimately vanished in its own self-made greenhouse storm? Skeptics argue we are stretching the data too far. They remind us that natural systems can indeed produce strange and complex patterns, and that extraordinary claims require truly extraordinary evidence, more than just unusual numbers on a graph. And that is a fair point. But if we consider how little would remain of our physical structures in 10 or 20 million years, the case begins to strengthen. Our skyscrapers would dissolve into dust. Our satellites would fall from the sky. But the gases in the air, the isotopes in the soil, the sudden chemical scars in the ice, those would endure. And if someone found them millions of years later, they might wonder the exact same thing we are wondering now. The atmosphere doesn't just record weather. It records civilization. And if civilizations came before us, their rise and fall may be written in invisible ink, frozen forever in bubbles of ancient air. But air and ice are only part of the story. There is another record, one far more dangerous, locked not in gases, but in the very atoms of the earth. A record that suggests someone, long ago, may have unleashed the fire of the nucleus itself. In 1972, deep inside a uranium mine in Oklo, Gabon, scientists made a discovery that shook the foundations of physics and geology alike. At first glance, the ore looked ordinary, uranium-rich rock, much like that mined in countless other places around the world. But when researchers tested its isotopic composition, they found something impossible. The uranium had already been burned. The isotope ratios were precisely what you'd expect from fuel rods inside a modern nuclear reactor. In other words, at some point in deep time, chain reactions had occurred spontaneously inside the Earth itself. This was a staggering revelation, because natural nuclear reactors were thought to be utterly impossible. And yet, here was undeniable evidence. Self-sustaining nuclear fission had taken place, nearly 2 billion years ago. Geologists rushed to explain it. Conditions at Oklo, they theorized, were uniquely perfect. Groundwater had slowed down the neutrons just enough to sustain the chain reaction. Nature, against all odds, had built its own nuclear power plant. But the discovery also proved something else, something far more unsettling. Nuclear signatures are extraordinarily durable. Even after billions of years, the isotopic fingerprints of those reactions remain sharp and clear in the stone. That realization opened a disturbing question. If our own civilization were to vanish tomorrow, nuclear traces would last long after our cities eroded away. The fallout from weapons tests, the spent fuel buried underground, the radioactive isotopes seeded across the planet, all of it would still be detectable millions of years into the future. Nuclear activity, once unleashed, cannot be truly hidden from time. Which brings us to an even greater puzzle. Why do we find nuclear-like signatures in rocks that predate humanity by tens of millions of years? In Kazakhstan, uranium deposits contain isotope ratios eerily similar to those created in controlled tests. They don't match what natural reactors like Oklo would produce. Instead, they match what a weapons blast leaves behind. Across 6 continents, geologists have recorded anomalous layers containing artificial-seeming isotopes, plutonium, cesium, strontium. Elements that simply don't occur naturally in the concentrations or arrangements where they were found. Some are the kind of isotopes modern reactors produce only under tightly regulated conditions. And yet, here they are, frozen in ancient stone. One sample pulled from Greenland's deep ice cores contained radioactive isotopes that would have required technology more advanced than anything humans had built until the mid-20th century. That ice was hundreds of thousands of years old. If those isotopes weren't natural, then someone, or something, left them behind long before us. The implications spiral outward, chilling and profound. Sediment from the Pacific Ocean shows plutonium traces that line up almost perfectly with one of Earth's greatest extinction events. If natural disasters had been responsible, we would expect volcanic gases, asteroid debris, or methane spikes. Instead, we see isotopes that can only come from nuclear detonation. Was it a catastrophic coincidence, or were we staring at the chemical shadow of a war that wiped out entire ecosystems? What makes the evidence even more unsettling is how systematic it looks. In some geological formations, isotopes appear in neat pulses, intense activity, then nothing, then another pulse thousands of years later. It's the pattern you'd expect from a society testing advanced weapons, not a chaotic geological process. Ancient myths, strangely, seem to echo this. In India's Mahabharata, warriors unleash weapons that make the sky glow like a second sun. Whole cities vanish in blasts that leave survivors hairless and ill, their food and water poisoned for generations. Mainstream historians often dismiss these as allegory, poetry, or exaggeration. But when compared with the geologic record, these stories sound eerily familiar. To be clear, science has not declared any of this definitive proof. Natural explanations always exist, and caution is absolutely necessary. Yet, every anomalous isotope, every radioactive fingerprint discovered in the fossil record, forces us to ask, are we really the first? Or are we walking across the ashes of predecessors who split the atom long before us, only to destroy themselves in the very fire they unleashed? Because if nuclear ghosts linger in the rock, they are not just records of destruction. They are warnings. And if we fail to listen, then we too may become nothing more than another layer of isotopes buried in the stone. One more vanished civilization in Earth's repeating cycle. If you want to know what will truly define humanity's presence on Earth for geological time, don't look at the tallest skyscraper or the largest city. Don't even look at monuments carved in enduring stone. Look instead, at plastic. From the first cellophane wrappers to the vast oceans of microplastics now drifting in every current, our world is saturated with it. Plastic particles fall in rain, settle in snow on remote mountaintops, and swirl in the deepest ocean trenches. Scientists have even found them frozen in Arctic ice, and embedded in the organs of animals. Long after our machines rust and our glass crumbles, plastic will remain, pressed into sediments and fossilized into new rock. Geologists call this future layer the plastiglomerate. And it may be the single clearest geological signature of our age. Now, imagine finding something like that in rocks far older than humanity. That's exactly what some researchers claim to have discovered. While drilling cores from the Pacific and Atlantic seabeds, scientists uncovered polymer-like fragments in sediments dating back tens of millions of years. At first, the explanation was simple: contamination. Modern drills, storage tubes, or even lab equipment could easily introduce plastics where they didn't belong. But contamination checks grew stricter, and in certain cases, the anomalies persisted. Some fragments were buried too deep in layers sealed long before humans evolved. Under microscopes, they looked nothing like natural polymers such as amber or bitumen. Instead, they showed repeating molecular chains, organized, synthetic-looking structures, more like polyethylene or nylon. To make matters stranger, some of these fragments resisted heat and ultraviolet breakdown better than many modern plastics. If they weren't contamination, they might represent engineered materials designed to endure for geological time. Materials, in other words, that someone meant to last. And plastics aren't the only anomalies. Tiny metallic beads and fragments have been found in sediments around the world. Their chemical makeup sometimes shows alloys, combinations of metals like nickel, chromium, and iron that rarely occur together naturally. In certain cases, they mirror the compositions used in modern stainless steel. Volcanic activity or meteorite impacts can fuse metals in strange ways, but the uniformity of these ancient samples suggests intention rather than accident. To be clear, most geologists treat these reports with immense caution. Contamination is the simplest answer, and extraordinary claims demand extraordinary evidence. But patterns matter. A fragment here or there could be dismissed. A scattering of them across oceans, continents, and geological layers begins to whisper of something larger, of activity that flared briefly in deep time, then vanished. Think of how our own footprint will look millions of years from now. Imagine a geologist in some distant future drilling into the crust. They won't find intact skyscrapers or rusting cars. They'll find a thin horizon filled with strange materials. Aluminum, nearly absent in nature until humans smelted it. Synthetic polymers, unknown to biology. Alloys arranged in ratios nature rarely produces. A chemical soup of fertilizers, pesticides, and industrial byproducts. To them, we will be a layer of anomalies, unmistakable but fragmented. So, when we look at ancient sediments and see polymer-like fragments and engineered-looking alloys, the mirror effect is hard to ignore. These are exactly the kinds of traces our own civilization is leaving behind. If they are contamination, they are frustrating coincidences. If they are genuine, they are whispers of predecessors who rose, industrialized, and left only their garbage behind. Just as we are doing now. There are even stranger claims on the fringes of archaeology. Out-of-place artifacts, objects that appear to defy the age of the rock around them. A metallic sphere found inside a 600-million-year-old lump of coal. A chunk of aluminum resembling machine parts, pulled from a Romanian quarry. Most of these are dismissed as hoaxes or misinterpretations, and many probably are. But the persistence of such stories, combined with genuine anomalies in sediments, keeps the question alive. What if some are real? What if they are relics of industries erased by time? What makes this idea chilling is how invisible industrial civilizations would become after collapse. A few thousand years, and forests would reclaim cities. A few million, and glaciers and oceans would erase the landscapes entirely. But the materials, the plastics, the alloys, the durable synthetics, would remain, buried and waiting. And that is, perhaps, the greatest warning. We are producing the very evidence that would convict us as a civilization, even if all else fades away. Plastics that will outlast our languages. Alloys that will outlast our governments. Chemical fingerprints that will outlast our species. Someday, another intelligence could look at our traces and wonder, as we now do, whether they are seeing the legacy of a people who rose, burned brightly, and then disappeared. If Earth hides such materials from earlier ages, then perhaps they are not accidents at all. Perhaps they are the fingerprints of civilizations that came before, who reached into chemistry and engineering, scattered their creations across the planet, and then were lost to time. And if they reached that point, why assume they stopped at Earth's surface? For if industry and technology once existed here, the next logical step is outward, into orbit, onto the moon, into the solar system itself. And that is where we now turn, to the evidence that may lie not in stone or ocean, but beyond the Earth itself. When we think of civilizations, we picture them rooted to the earth, bound to rivers, plains, and coasts. But in just a handful of generations, humanity has leapt from stone tools to space flight. We've put satellites into orbit, footprints on the moon, and probes beyond the solar system. If our story ended tomorrow, some of our most enduring traces wouldn't be on Earth at all. They'd be floating silently above it, or waiting on airless worlds. And that raises a haunting question: if we've already spread artifacts beyond our planet in just a century of industry, what if another civilization had millions of years to do the same? If they reached for the skies, what clues might they have left behind? The first whispers of this possibility came not from telescopes, but from radio antennas. In the early decades of the space age, engineers noticed something odd: long-delayed echoes. Radio signals sent from Earth would sometimes bounce back several seconds later, far longer than normal reflections. Some scientists thought it was atmospheric interference or reflections from the moon, but others wondered, what if something artificial was out there, catching and replaying our signals like a mirror in the sky? The phenomenon was never fully explained, and it eventually faded into obscurity. Yet, it planted the seed of an idea: maybe Earth's orbit isn't as empty as it seems. That idea exploded into public imagination with the story of the Black Knight satellite. In the 1960s, radar operators detected strange objects in polar orbit at a time when neither the United States nor the Soviet Union had satellites in that position. Later, during missions in the 1990s, astronauts photographed a dark, angular object drifting above Earth. NASA insisted it was space debris, likely a lost thermal blanket, but to many it looked too strange, too deliberate. Conspiracy theories spread, claiming the Black Knight was an ancient satellite, perhaps thousands of years old, left by a forgotten civilization. The truth is probably mundane, but the symbolism lingers. If humanity collapsed tomorrow, our satellites would continue circling Earth for centuries. Some, in stable orbits, could last tens of thousands of years before decaying. To any future intelligence, they would appear just as mysterious as the Black Knight does to us. If orbit is the first place to look, the moon is the second. Unlike Earth, the moon has no atmosphere, no weather, no erosion. Artifacts there could last millions, even billions of years. Already, Apollo astronauts left behind flags, rovers, and scientific instruments, silent markers of our presence. If another civilization had visited long before us, their traces could still be up there, buried just below the dust. Some anomalies fuel speculation: reflective flashes seen in craters, glassy beads scattered across the surface in unnatural clusters. Officially, these are explained as volcanic glass or impact melts. But what if some are remnants of industrial processes, mining slag or debris from ancient activity? It's a provocative thought, especially when we remember how permanent the lunar surface can be. If we can leave tracks that may last millions of years, why couldn't others have done the same? Then there's Mars. Billions of years ago, it was a world of lakes, rivers, and perhaps oceans. If life had the chance to evolve there, intelligence might have followed. When Viking probes sent back the first close-up photos in the 1970s, one image electrified the world: a mesa in the Cydonia region that, in the shadows, looked like a colossal face. Later, higher-resolution images revealed it as just a natural formation. But the excitement it caused revealed something important: we are primed to see meaning in anomalies. And yet, Mars still holds mysteries. Meteorites blasted from its surface contain unusual microstructures, once argued to resemble fossilized bacteria. Certain mineral deposits suggest chemical processes that, while explainable, don't quite fit natural expectations. If Mars once had an intelligent civilization, its ruins could be buried under kilometers of dust and sand, invisible to orbiting cameras. Only deep exploration, drilling, excavation, could confirm or deny it. And given Mars's ancient habitability, the question remains tantalizing. Beyond Mars, we reach the asteroids. To us, they are treasure troves of metals: iron, nickel, platinum, cobalt. Already, companies are planning to mine them. And if we succeed, the scars of excavation will remain visible for millions of years. Some asteroids already show oddly geometric ridges or grooves that don't quite match natural models of rotation and impact. Most are probably coincidences of geology. But again, we're forced to consider the mirror: if we would leave those marks, why not others? Some scientists even suggest searching for technosignatures closer to home. Instead of scanning the stars for alien radio signals, what if we scoured our own solar system for debris, artifacts, or mining scars left behind by civilizations that came before? In recent years, the idea has gained traction. A rock like Oumuamua, passing through our system, sparked debate about whether it was natural or a fragment of technology. If fragments of civilizations can drift between stars, then evidence might be closer than we think. This leads to a sobering thought. If traces exist in orbit, on the Moon, on Mars, or in the asteroid belt, they may outlast every other clue on Earth. Our planet erases itself with erosion, with tectonics, with oceans. But space preserves. Artifacts up there may be the truest legacy any civilization can leave. So, as we stare into the sky, we might not just be looking outward for others among the stars. We may be looking backward, into the deep past of our own world. And if we find something, the question that will echo louder than any other is not just what they left behind, but why they vanished. And that brings us to the final, most unsettling part of this journey. The repeating pattern of civilizations rising, shining, and falling into silence. When we tell our own story, we tend to imagine it as a straight line. A journey from caves to cities, from sparks of fire to nuclear stars, from myths to science. But history rarely moves in straight lines. It loops. It collapses. It erases itself. And when we zoom out far enough, past the rise and fall of empires, past the flicker of cultures and kingdoms, what we see is a rhythm. Civilizations don't just rise, they rise and they fall, again and again. The Romans believed they had built something eternal. Their aqueducts cut across Europe. Their armies stretched from the Atlantic to the Middle East. But drought, disease, corruption, and the slow, grinding weight of overextension brought the empire to its knees. The Mayans built vast cities hidden in the jungles of Central America, aligned with the stars, glowing with art and science. And then came collapse, environmental stress, war, shifting trade, perhaps even rebellion from within. The great cities were swallowed by trees. Their voices silenced. Angkor in Cambodia, Easter Island in the Pacific, Cahokia in North America, each tells the same story in different words, brilliance followed by silence. Now, extend that same rhythm into the deep time of Earth. The fossil record is a ledger not just of life, but of collapses, bursts of creativity, sudden extinctions, fragile recoveries. The Cambrian explosion, when complex life appeared almost overnight. The great dying at the end of the Permian, where nearly all species vanished. The extinction that cleared the dinosaurs and opened the way for mammals. Each of these looks eerily like the rise and fall of civilizations, written in biology. Sudden ascent, violent collapse, a reset. If intelligence has risen before, this is what it would look like. Not cities preserved in stone, those vanished too quickly, but scars in the earth itself. Carbon spikes frozen in sediments. Isotopic fingerprints that don't match natural processes. Synthetic particles embedded in ancient rock. Traces of technologies that outlast the builders, but not the meaning. Each cycle would leave a pulse of activity. Each collapse, a silence. And then the planet tries again. That cycle has a name in modern astrobiology, the Great Filter. It's the idea that life may be common in the universe, but intelligence rarely survives its own adolescence. Civilizations may bloom like flowers, but most wither before they see the stars. The silence we hear when we point our telescopes outward may not mean we're alone. It may mean most others have already burned out. What's terrifying is how well the Great Filter fits our current trajectory. We've split the atom and salted the soil with isotopes that will be readable millions of years from now. We've pushed atmospheric CO2 to levels not seen since prehistoric hothouse Earth. We've covered the oceans and continents with plastics, leaving a layer of synthetic dust that will never fully decay. In just a few centuries, we've produced the exact kinds of anomalies scientists now puzzle over in ancient rocks. We're already the ghost of a civilization future geologists would wonder about. We began this journey with something small, metallic spheres sealed in stone. Objects so strange they made us question whether we truly know our own past. From there, we followed the trail across fossils, atmospheres, isotopes, polymers, the moon, and the stars. Each clue was faint, each fragment incomplete. But together, they whispered a possibility almost too large to comprehend, that we may not be the first civilization to walk this earth. And if that is true, then we're also not the first to fall. The fossil record pulses with extinctions and recoveries, a rhythm that feels less like accident and more like memory. The isotopes, the atmospheric scars, the inexplicable anomalies, they may be warnings written into stone, saying others were here. They reached this point, and then they vanished. But there is another way to read them. Perhaps they are not only warnings. Perhaps they are proof that intelligence itself is resilient. That consciousness rises again and again, like a flame the earth cannot extinguish. If so, then we're not standing at the edge of a cliff, but at a fork in the path. Collapse, one direction; endurance, the other. The silence of the cosmos presses on us. We see no galactic empires, hear no voices from the stars. Perhaps the filter is real, and most civilizations destroy themselves before they spread. But silence is not proof of failure. Silence is an invitation. If no one has survived long enough to leave a clear beacon, then maybe it is our role to be the first. Because the greatest mystery isn't whether others came before us. The greatest mystery is whether we will be here tomorrow. 1 in 2277.